Hi. AWS launched RoboMaker in 2018 to solve cloud robotic simulation. They validated the market, got real customers, then shut it down last September. Foxglove raised 58 million for robotics data infra. VM raised 117 million for fleet management. The tooling layer for robotics is like a massive market. And right now, the simulation and development layer has no incumbent. The problem isn't that there aren't good simulators. There is Gazebo, there's VBot, and there's Isaac Sim, which is incredible if you have thousands of dollars in GPU. And The problem is everything around the simulator, finding your robot model, setting up ROS or ROS2, which works uh, for your robot, where packages exist, authoring environment in XML, writing control code from scratch, debugging with zero AI assistance, and then after all that, having absolutely no standard path from simulation to shipping real hardware software. The ecosystem is fragmented. ROS is here, Gazebo is there, models are scattered across GitHub, physics configs are proprietary for formats. Getting robot from purchase to doing useful work take weeks of setup before you can start writing a single useful logic and setting up the whole CI/CD. That's what we're trying to fix. Um, what you see in front of you is Gazebo running with ROS2, and we have a few digital twin templates of empty world, warehouse, obstacle course, and my roommate's coffee table area, which we uploaded using our phone. You can spawn different types of robots, and I have one spawned here already. Um, and Yeah, like you can, and this just doesn't give you a simulation and spawning. You can write code using Jupyter Notebook um, for basically Jupyter is running, and it's kind of like connected to your session. So each user has a session where we give them a Gazebo simulation. We also are trying to onboard VBot and NVIDIA's Isaac Sim, and we allow people to connect to the simulation and write code. Jupyter is somehow malfunctioning on our infra, but I'll show you another thing. Like when you say like move forward 2 meters, um, it writes all your code and executes it on the Jupyter notebook, and you have the code for whatever you write here. It is executing, so it takes a little bit of time. Um, okay, so I don't know if you could see it went 2 meter. Let me move it a little bit more. Move for move backward 10 meters. So also, yeah, so talking about the architecture, let me tell you what's actually happening here. This isn't just a chat GPT wrapper. PlatformY runs a real Gazebo simulation instance on cloud infrastructure. Right now it's on GCP. Each user gets their own isolated session with their own simulator process, their own WebSocket, their own ROS2 bridge. Sessions are session first, isolated, concurrent, and cleanable. Uh, we we have a AI layer sitting on top of that, Gemini Flash for fast code generation. We use Gemini Visual for spatial understanding. That is, you can upload videos in environment, and it can spawn your environment use case for you. Actually, uh, so basically, you. So I have a DA. This was my roommate's coffee table. I don't know if you can see there's a sofa here, and there are the walls here. Here is a rush. So you open, you upload it, you convert it into SDF, and it will start a backend process to start onboarding to the world. Like when I say world, it will add it here eventually. Once it converts and processes that, it takes a little bit of time. So I did it beforehand. So I think. Um, uh, this one loads it up. It's taking a little bit time. Yeah. And now um, there's here's what makes the platform not just app. We're building MCP server, a model context protocol. That means any MCP compatible like Claude Cursor, Windsurf, or any LLM agent you have can connect to PlatformY as robotics backend. Developers using Claude code can test my navigation algorithm in a warehouse. Claude will call our MCP server, spin up simulation, run the test, return results. We're not just UI, we are a robotics layer for AI ecosystem. And the bridge goes both ways. Physical robots can query platform Y for validated models and paths. You test in simulation, you deploy through MCP. That simulation to real bridge, that's the thing nobody has built yet. Three things are converging right now that makes this important. Uh, Consumer enterprise is exploding and actually running over time. So I'll stop here and then I'll share more in the demo tomorrow.